Good to see it. Good to see everyone. And I think we'll probably go off video just because most people can hang out on video. It's all good, however people want to participate. So I'm Daniel. I'm the president of the Active Inference Institute. And so it's great to see co-founder Alex V here, and Holly's on our scientific advisory board. And so in the active inference ecosystem, as our introductions kind of evidenced, people are coming from many different angles. And today we're going to be exploring decentralized science, DeSci. We're going to be learning by doing. I'm going to allow one person in. So it should be a great session. It's going to be a little bit less than 2 hours. And by the end of the session, we will have published an actual scientific artifact. We will be co-authors in a DeSci way. So how is that going to happen? Why is that going to happen? What does that teach us or reveal about other settings where we can transfer these kinds of lessons to? That's going to be kind of the strange loop that we'll find ourselves in. So I'm allowing one person into the room. Okay. I'm going to share my screen. Greetings, dog. Would you like to say hello before we begin?
Seems like
Dog.
his audio is still connecting.
It could be a super conscious human, could be a super conscious AI working with all kinds of systems is going to be a key topic because one truly never knows. So I'm sharing a screen here and I'm putting a link here. So of course we can go into more detail and context on the Institute and all of this, but here's the short version. This is the Active Blockference project. So this is an ongoing project at the Active Inference Institute that we've been working on since around the Institute since 2021, and starting Active Blockference shortly after. And we're going to talk more about what Active Blockference is, but we're doing it on this page because it's open science, it's DeSci, we're 100% in the game. This is our real document. This is how we do research. This is how we highlight accessibility and participation and inclusion and documentation and all these other things that we expect and prefer in our current and future epistemic niche. So the platform is coda.io, and hopefully you'll see the different affordances that you have on the platform. But please, for any reason, you can raise your hand in Zoom or ask a question in the chat. And by feeling comfortable with the tool, hopefully we can have some really co-creative outcomes. And so I'm just going to hide the sidebar on the left. Here's the big picture. This is going to be a slightly less than 2-hour participatory session. The first few minutes, as we just concluded, were just some introductions and context, and then we started recording. So we're on track so far. No one get too worried. The middle section, the sort of substance of the sandwich, is going to be applying the active entity ontology for science, or AOS. We're going to work on this page. Everybody who has the link has the edit access. It's going to be totally collaborative, and it should be such that you can do it anonymously. And where we're going to get to, although of course I don't know all the details or all the other avenues we'll explore, is we're going to generate a GNN model, generalized notation model, of an active entity ontology for science, AOS, DeSci system. So we're going to generate a GNN system for AOS for DeSci, and then we're going to publish it. All these terms and acronyms, we're going to explore more. I just wanted to throw the fastball down the middle because that's where we're going to get to. And in the last minutes, probably around the last 30 minutes, we're going to polish up and publish this page. And I'm going to do that by going to these 3 dots and literally saving a PDF. Then we're going to head over to Zenodo, which is not blockchain based, but helps us understand as a publishing affordance where instant publishing and verifiable publishing and all of this could come into play. And Zenodo is like a no gatekeep preprint server. So it allows you to instantly upload your paper and get a DOI, which is kind of like the identifier number for scientific literature. Like books have the ISBN, but scientific papers have the DOI, the document object, a digital object identifier. And so we're going to complete the table with our author information for people who want to, download the page as a PDF. So everything's going to happen on this one page, and then upload it. Will literally be actual DeSci co-authors. And then we'll kind of have an instant post-mortem and explore how could we have done things better? How can we see the situation as a microcosm of a DeSci scenario? I mean, what happens when 10 humans and 2 AIs walk into a Zoom room, and then what? So that's like the exact question. And so whether that's happening in a legacy institution, like a university anywhere in the world, whether that's happening in a group of friends who are like, hey, I'm kind of getting interested in this topic or that topic, or whether it's a high reliability team for critical infrastructure, any number of these settings, we want to be able to have flexible ways of modeling and understanding and sense making and acting. And so that's going to weave through hopefully what we can explore. I'm going to start with some more background and information just to spin up quickly on it is already an active Inference narrating the introduction indeed, but I didn't have the video deepfake ready, so that's why. Just to give a little context so we can share a reference frame on active inference and also on this project specifically, but everything is clickable. Everyone is able to be in this document. And after the session, I'll probably flip it back to anyone can comment. But please, if you want to continue participating, this is what we do in this project. And also, again, you can raise your hand or write in the chat. And just, if you have an uncertainty, let's just resolve it in real time. Okay, so by way of beginning with blockference, and then we'll get to active inference as a more theoretical basis for blockference, I'm going to go to spinning up with blockference. So active blockference, it's a software package. It's implementing classic and novel active inference models. So we're both replicating what we see in the literature, and we're also generating new situations. And we're using the system simulation framework CAD-CAD. So some people in Trusted Seed or in Web3 might be familiar with block science, with Zargum and Jeff Emmett and Chris Katoya and all of our colleagues who are in the CAD-CAD space. And we can think of active blockference as like active inference plus CAD-CAD. So here's some more detail on the project, which I'll skip through. CAD-CAD and more broadly block science and block science labs help us run complex systems simulations in a really clear and reproducible fashion. So here's some information that you'll find on the CAD-CAD framework, and also recently / ongoingly, they are versioning from a kind of 0.4 version into what they call the reference implementation, which is framed formally in terms of generalized dynamical systems, such that multiple code implementations, I believe Julia, Python, and Rust at this point, will be able to speak the same language at that kind of higher level or deeper level of interoperability. And CAD-CAD, there's some great demos and explanations, but I'll just show one piece. Despite block science having block in its name and active blockference having block in its name, it's actually not a blockchain specific system. Rather, a block is like one time step of a simulation. And so CAD-CAD gives extremely nuanced ways of talking about what happens within and between time steps of a complex systems simulation. We're going to kind of see how that comes into play, but at some level of granularity, we can say like CAD-CAD is kind of like our operator for complex system simulations. If we want to make sure that one thing happens before another thing, or if we want to track and do a parameter sweep and understand how changing one parameter influences another, and then kind of explore the space with a whole spectrum of simulations, you could do that for a hydroelectric dam, you could do that for blockchain and elsewhere. And they've done Ethereum system models. So it's been used for economic systems and so on. And the piece that active block fronts adds to the picture, and the reason why we even started on this whole journey, thank you, Kyle, farewell, was that while CAD/CAD has incredible tools from kind of like a macro perspective, like macroeconomics or structural aspects of different settings, sometimes these structural settings involve agents who are cognitive, like humans or decision-making systems. And so we wanted to bring this kind of cognitive modeling as a bottom-up micro agentic framework into CAD/CAD, which otherwise takes a really top-down structural perspective. PyMDP is a Python package for implementing active inference generative models. And so that's just one of the common tools that are in play. So basically, active block inference wraps PyMDP with CAD/CAD so that we can implement active inference generative models with the kind of reliability and systems engineering perspective that CAD/CAD gives us. For those for whom that was just a lot of information or feel that way in the future during this session or otherwise, we have a lot of image memes. We connect them to the active inference ontology so we can kind of have our meme Rolodex. So it's like, when I say GM, I mean generative model. Web3, we love GM. We love generative models in active inference. And so there's just different silly things that you can see. But of course, there's a grain of truth. And it's interesting when people want to convey these ideas in different ways. But the image memes, they're out there. All right. Again, I'll be like looking if anyone's raising their hand or a question, but I'm just going to continue on through this background session part so that we can get to the part where people are welcome to edit. But you can go to the link, which I'll put again in the chat, just so that you can have it up and see that you can click and explore these things. So active inference is a first principles framework for perception and action. If you really want the 0th layer understanding of active inference, it's right there in the title. Action and inference. So action and thought. And here's figure 1.1 in the textbook. That link will take you to another Coda document where we carry out the textbook group, but we're just going to use the images here. This is the setting that active inference is concerned with. We have an agent who receives observations from the world, and then the agent is also able to act in the world. And so you can have a simple system like something that's receiving observations but not taking action, like a passive system. That's okay. That's like a special case of active inference. But also, most interestingly, we can have all manner of simple, all the way on through sophisticated cognitive agents that have a really, really nonlinear mapping between observations and actions, like somebody looking at the color of a light in a room and then using that to undertake some plan. If we go one more level into detail of this cybernetic loop, which, by the way, is the input-output structure of an API, this is all agent-based modeling. This is just input-output. This is not controversial. It's just a way that people have modeled agents in their niche. We can go into one more level of detail. So here, the observation that's coming into the agent, it's not just like the truth drop is coming in unadulterated, but rather what's happening in the moment of cognition is that observations are coming in while the agent or the organism is making ongoing predictions about what those observations are going to be. And then what gets propagated upwards in the cognitive system is not like the raw sensory data, nor even really the processed sensory data, but rather a discrepancy between the observation and the prediction. So this is sometimes called predictive processing. And it's also a really useful way to think about not just how biological systems work, but in some ways, the information theoretic or the computationally optimal way to deal with complex observations. And just like with our visual experience, we know that what we're doing in the eye is not just processing incoming photons. That's like kind of a passive take on vision, as if the data from the retina just gets progressively processed and refined all the way on up through the perceptual apparatus. But we don't perceive our blind spot. That kind of gets conveniently filled in. And our whole visual field has, in regular vision, similar amounts of color and resolution everywhere, because we expect the world to have equal amounts of color and clarity everywhere. However, that is absolutely not what the structure of the retina is. And so really the retina is just giving these sparse and noisy observations that are being merged or melded with ongoing predictions. And that is what generates our visual experience. And that's exactly what a variational autoencoder does. For people who are more familiar with that kind of Bayesian machine learning, active inference is like a variational autoencoder with action. So it's not just doing prediction on perception, it's doing prediction on action. And there's always some non-zero discrepancy outside of toy in silico examples, because the world's complex and we use simplified heuristics. So at least to some rounding point error, there's like a non-zero discrepancy. And there's two ways that then the agent can respond to this discrepancy: perception or learning, which is changing beliefs, or action, change the world. So I expect and prefer that it's 37C. I'm getting the observation from the thermometer that it's 30C. So the discrepancy, its temperature is too low observation. So one way to kind of reduce that discrepancy is just say, okay, fine. Now it's 30 degrees. All right, next one comes in, 30, no discrepancy, it's all good. Or you could take action in the world. And just to add one more level of detail on active inference, though it's, of course, a large topic, we operationalize what we just saw one level finer, which is that we have the agent, here's on the right side, which is the brain in this setting, and we have the world. And they are separated or made conditionally independent from each other through what is called a blanket. And the blanket consists of two kinds of nodes. In this representation, a node is like, it could be a variable in a program or a mathematical number, but it's a random variable on a Bayesian graph. But it could be, you could have a variable for each of these four things in a program too. The blanket consists of incoming statistical dependencies. Those are called sensory states and associated with perception, and outgoing statistical dependencies, which are called active states associated with action. So it's exactly what we saw here, except just a little bit different in a way that turns out, though we won't explore it too much today, this has some incredible mathematical properties that end up making the composability of these kinds of models absolutely exquisite. So that's why people are excited about active inference, because it takes the classical cybernetic agent-based modeling perception action loop and it operationalizes it in a way where we still have that kind of system independent description. So we could apply this to API calls, incoming and outgoing. We could apply it to a deliberative democracy, input information and decision-making, or a brain or the liver. So being able to talk about different systems, ecosystems in this unified and composable way is really one of the most exciting pieces of active inference. And just to show a few recent topics as we kind of navigate our way towards decentralized science, here's a very influential paper from about 6 months ago, Designing Ecosystems of Intelligence from First Principles. And here, Carl Friston, who's one of the primary authors in the field, and many other colleagues, especially from Versus, which is a company that's applying active inference, lay out something like a synthesis and a roadmap for the developmental directions of the field of artificial intelligence in the next decades. And just to kind of put this into one point, rather than developing larger and larger monolithic models, they use what they call shared intelligence or ecosystems of shared intelligence, where you have competent phenomena and systems properties like robustness and resilience through the interactions of diverse and heterogeneous agents. And so like the functionality of a forest to do this or that service or to respond to this or that perturbation, it's not like there's a monolithic tree that's making that call, but rather you have all kinds of different entities across different species boundaries through their local natural engagement that give rise to this intelligence. And so it's happening that way in ecosystems. And that's why they use the ecosystem metaphor, or more than a metaphor, to talk about how we can use active inference to design these composable ecosystems of intelligence from first principles. So that's one cool paper. Another very recent paper that also speaks to the transferability of active inference models across setting was, again, from a similar team, subset of the authors above, designing explainable artificial intelligence with active inference, a framework for transparent introspection and decision making. Now, this one is something that we can also go into more detail into, but I'll just show the kind of first active model and then where they get to. So this is what a generative model looks like, one representation of it. Each of the nodes is, again, you could think of it as like a number, or more properly, like a program variable. So they're not all just like 4, 12. They could be like a vector, or it could be like a matrix or a tensor. But this is kind of the connectivity architecture that can be applied to different decision-making entities. And we're going to return to that in the context of different entities in DeSci ecosystems. But what's really exciting about this paper is they bring a figure, absolutely copied and pasted with attribution, a model that was initially generated to describe computational phenomenology. So computational modeling of first-person experience. And this model specifically was developed around attention and meta-attention, or awareness of attention. And so it's not just that these kinds of generative models can be composed laterally. So you can't, it's not just that you build ecosystems of interacting agents, kind of bumper cars, like all on the same level and bumping into each other, but you can also generate so-called nested models. So for example, in the yellow layer here, this is like the perception and action happening at a closest to the sensory motor level. The blue layer is an attention layer, hashtag transformers, hashtag attention is part of what you need. And the purple layer on top is a meta awareness. How aware am I of what I'm paying attention to? And so this is, again, coming from computational phenomenology. However, they're deploying it in the context of reflexive or deliberative artificial intelligence systems to promote explainability and transparency. So that's kind of what's cool about active inference. Again, to emphasize, is the generative models that one builds for a given system of interest can actually be transposed extremely easily. And recently I heard someone say, and I think it's a cool way to think about it, is in active inference, you spend a lot more time understanding and building the problem, and then you let the agent solve the problem. So it's not that you're setting up the system that solves the problem via solving the problem yourself. It turns out that by following the recipe for generative modeling and building your comprehensive summarization and operationalization of a given system of interest, then this architecture is the one that's actually going to do that work. So it's kind of like second level systems design when we're designing cognitive agents, because we're scaffolding them so that they can be deployed in a certain way. And so that's puts a step of space in between how sometimes people do try to engineer outcomes in ecosystems, but rather than, oh, the blood sugar's low, so spike the sugar, and now it's high, and so do this, you can pull back and what is the endogenous mechanism of regulation here? And then what kinds of cognitive functionalities might be added or modified to support the system's resilience around some desired state. So we're going to come back to that in the DeSci setting. But that is kind of the overall active background and showing how it's being used in the development of artificial intelligence systems or synthetic intelligence systems. Okay. Again, write in the chat or feel free to raise your hand, and I'll reshare here the link. Welcome, Matthew. So moving on to the kind of two pillars of what we're going to do when we, in the following about hour, write a paper. In 2022, with a bunch of colleagues from the Institute, we developed an active inference ontology for decentralized science, from situated sense-making to the epistemic commons. And what we presented is called AOS. AOS is an active entity ontology for science, although one could imagine it's also for things other than science. And ontology is just like taxonomy. It's a way of organizing things. And most broadly, what AOS does is it gives us like a library or a zoo of two kinds of entities: informational entities and active entities. Informational entities are kind of like static knowledge objects. They don't engage in action selection. So they could represent like a publication, or it could be a fungible or non-fungible asset. It could be a static data set. It could be intellectual property. So, and this is obviously what we can co-develop. We just add a new row and we have a new informational entity. So this is like a well-typed schema system for different informational artifacts without worrying too much about how a PGP key is different from an NFT, is different from a PDF on some publisher's website, because we really wanted AOS to be able to describe legacy and contemporary and future epistemic ecosystems. So this is also not necessarily like blockchain limited or based, but we can absolutely address it within the framework. So informational entities are the components of information that are shared in the ecosystem, but they are not decision-making entities. In contrast, active entities are those that take actions. And as we've been exploring, we can use the same kind of generative models to create and compose active entities, whether they are singular humans, whether it's an organization or a team made up of humans, whether it's a DAO, university, different research agencies, funders, companies, publishers, communities of practice, scientific auditors, all of these different levels and scales and types of active entities. And then we can basically nest different entities within each other if we want. So this nesting is happening inside of one agent. It's a nested generative model that's reflecting, again, their attention and meta attention. But we can also nest kind of like a Matryoshka doll with like a human, and then nested inside of the team, there's 3 humans. Okay. And then 3 teams are nested inside of the organizational unit. And then 4 organizational units nest within the academic university. And then you can just keep on going with nesting. And it's that ability to describe multi-scale systems from like, you could go all the way down to the cellular level of a person, if it were relevant, all the way on through the kind of Gaia scale or cosmic scale. It's just a question of how you want to model it. This is a really tool and approach and process-oriented framework. Active inference by itself provides very few answers, if any, to the things that people are curious about specific systems. It'd be like, what does a linear regression say about the relationship between smoking and heart disease? Well, nothing, because it's a tool. But you could use linear regressions appropriately or inappropriately to explore that question. But you wouldn't expect the idea of a linear regression to be opinionated on the relationship of something that's obviously very, very multifactorial and embodied. So that's why we have a generalized framework for perception and action that we use to build specific models like we're going to do today for DeSci ecosystems, so that then we can address questions related to specific systems of interest. But we really have to scope and build the problem and the setting rather than wait for some type of general answer from the active inference framework, because none will come. So these tables are also brought into Coda, and Coda is really cool because it allows us to call every row of a given document. So like we can mouse over. What is a DAO? Mouse over, and oh, it's a computational organization. Oh, it's an organization. And so we can take this to many levels of detail, but it helps us be clear that we're not just glibly talking, although in a sense, aren't we all? But also we're using essentially a controlled vocabulary. So when people say, wouldn't it be cool if there was 5 peer reviewers and they got paid this amount to review this paper? People do speak like that. And the point is that kind of natural speech should be recognized by systems, because we're only talking about a limited subset of entities. Thank you, Alexander. So when we're talking about DeSci settings, we might be interested in the interaction of humans and computer systems or other types of entities. But EOS is going to kind of bring this ecosystems of intelligence composability to decentralized to decentralized science ecosystems. And we think that this is one thing that's been sort of underappreciated in DeSci, which is various mechanisms and systems are proposed that may individually or locally be absolutely positive, but their secondary consequences may be very unclear. Like peer review is unpaid. We should pay peer reviewers. Okay, how much? 5 cents? $5? $500? What's the governance around how that amount is going to be determined? What new incentives does that establish? And so when we just look at one mechanism and implement one thing, we may not be aware of all the different consequences or lost opportunities to synergize. The last piece before we get to the DeSci is generalized notation. So this is a plain text notation for active inference generative modeling that allows us to work fluidly between using natural language and language models, making graphical visualizations, and having executable simulations with active block inference via CAD. So like if 2 nodes are connected to each other, we want to add a 3rd node and connect it. That shouldn't just be necessarily only drawn in a Miro board, but it'd be really cool if we could then use language models to re-describe the system in different languages and to execute that as a simulation. So this may change how certain decisions and designs are created, because it's not like there's a front room where people's feedback is accepted and then they take that into the back room and distill that and then do whatever they want with a simulation. There can be integrity across these different representations. And we're going to explore that when we get to the DeSci system of interest. So now, via raising their hand or just typing directly into these questions or adding more questions, what do we want to model about a DeSci ecosystem? And to look ahead, we're going to make a GNN representation of the DeSci situation of interest. And then that is going to be our work. We'll then add our names to this author table, and we'll publish the paper in about 45 to 60 minutes. So from now on, the kinds of modifications that we make here will be included in our work. So whoever would like to speak up or start typing in the place that I have put into the chat. What are we interested to model in DeSci? This could be an extant situation, like it could be a specific DeSci DAO, or it could be your research group. It could be your engagements when you're reading a paper or going to a Discord. These are real settings or hypothetical settings.
Probably, Daniel, I don't know. You can like suggest us something, and we can start from that. I don't know. I'm not an expert on this topic.
I am thanks. I'm definitely happy to, but no expertise is required because these are actual systems of interest.
Mm,
This is like, where are there frictions in epistemic commons?
oh, okay.
Or do we want to explore on the peer review side or the funding side or the team onboarding, just like real DeSci situations? What kinds of settings will DeSci or DeFi or any other area be confronted by that are going to be like leverage points or coefficients for its success? What is the real work of DeSci other than just getting super excited about science? Then what? Again, we can describe a specific situation. No situation is too trivial. A situation that we all have embodied experience with may be really helpful because while the framework is theoretical, these situations are not going to invoke theory in that way. That's setting the stage, like loading the linear regression into your software, and then now we're going to be in the system of interest doing the kind of systems description.
You mentioned something about onboarding, right? I think I mean that's a situation that is always present in Web3 in general. I mean, it is sometimes really hard to get into any organization related to Web3 if you don't have a previous background, or at least somehow yeah, some you, if you don't have a knowledge around some concepts, it is a little bit hard to understand what's going on. Exactly.
All right. Do we want to just explore onboarding in general, or do we want to just pick some specific onboarding case? Like to the TEC or something like that.
Yeah, we can use that, but that's as an example for the
Okay. So
activity.
to the token engineering commons. So and seeing this as kind of emblematic of onboarding into a commons. So I'm just selecting that it's a community of practice, just so that we know that, again, we're not in totally uncharted waters. We're talking about specific kinds of entities. So what are those what is this situation composed of in terms of active entities and informational entities? So what are the pieces of information? People can just type it as well. What are the pieces of information that are in the space? And what are the active entities in the space?
I understood that information entities are more static, right?
Yeah.
And okay. Could be under information entities. Could we place, for example, their forum, all the documentation they have, they store there? Okay. and under active entities. I don't know, but sometimes this concept of commons is something seems to be general, but at the same time could be a little bit what's the word, like you can adapt it a little bit because it is not the same definition, the same definition that probably it is in general use, and the one that Commons Stack provided it to you, the TEC, because they are using the technology of Commons Stack, for example, or they used the technology to launch the Commons. So, okay.
Yeah. There's, of course, a human being onboarded. And then what other active entities might be in that space? Anything that can receive bots.
Bots.
Yes.
Yeah.
Bots. Teams, a bot, a DAO. This can be anything that is receiving information and taking actions. So it's kind of a way in some sense to steer towards applicability when thinking about multi-level systems. Just with horizontal engagement and with the vertical nesting, it can get really like philosophical or speculative. But these are the real entities that are in this situation. There's the human who's onboarding. There might be also a human who's already a community member. Might be a team.
Stewards.
Yeah, different roles. So like when somebody joins, they have an onboarding role, but these are all the same entity type. So having the scheme that allows us to be like kind of use a template for a human helps us talk about then, okay, now we can talk about roles of humans. Okay, let's any other active entities or information that we want to explore in the space? So when you said, or for anyone who thinks about this, what is it that if you're a level 7 on, it's easier, and level 2, it's more difficult for a human?
Come again? What's the question?
Like what background features or knowledge makes it easier or more challenging for someone to onboard? Knowledge of what?
Well, basic concepts of Web3. What's Web3? What's blockchain even sometimes? That's, yeah, starting from the basic things to harder or difficult concepts, like token engineer in this case, specifically.
Okay. So now let's just we could imagine that we could keep on going, but we'll just try to rapidly move through it so that we get everything sketched. Thank you, Holly. Oh, different kinds of information. Yeah, audio visual information. Like if you wanted to have a video recording, then you'd want to understand which humans have access to audio or visual perception. So that's how a high reliability system can work hand in hand with accessibility. These are the things that need to be considered. Again, maybe the active inference prelude makes this sound really hypothetical, but this is just like a framework for thinking about the situation that we want to be thinking about. So there's nothing about the situation that is different for us just framing it a certain way. But it's like, either you're going to include pieces of information or entities that are irrelevant, which isn't the worst thing, or you're going to forget what is relevant, and then you'll have just simply made an error. So this is an accounting system for the kinds of entities that we want to include in our model. So this is how we operationalize holistic approaches to systems engineering, and not just from a top-down structural, like, well, this person will click this link and then they'll be moved to here, and then this API integration happens. That's like very mechanical and processual and top down. But like, what makes that person click that link? Are they doing it to resolve their uncertainty about something? Are they doing it for some other reasons? So it's like the bottom up view on people actually moving through the ecosystems. Otherwise, token engineering is like you build a playground scaffold and then no one plays in it. But like from the top down, the logistics and the operations, it was like perfectly built. But then, what if the pull-up bar is 2 feet off the ground? And so you didn't think about how a person would actually approach that, and then why they might want to use it or not. Okay. So, now we're going to, just for probably a limited subset of this, we'll focus on a specific setting and write a little GNN script. So this isn't going to be the final version. Again, it's all just to show this kind of like fractal DeSci moment that we're in. Greetings, Darren. I've shared the link in the chat where we're at. We're creating a cognitive model of a human onboarding into the token engineering commons community of practice. So we're characterizing which entities are relevant here and which pieces of information are relevant. And then we're going to develop a plain text representation that helps summarize that setting and move it towards being able to be described in natural language and visually and in a simulation. Does anyone else who hasn't spoken want to just like add anything at this point or ask a question or anything?
Sorry, Danielle, I have a question. So we have the active entities and we have the information entities, but I was thinking about how people really become active. For example, I'm missing some kind of interface. So we have documentation and you have the humans, but humans have to have access to some kind of hardware, software to be able to access information. That it's not important to specify this kind of entities also.
You're asking whether defining the interface is
Yes.
relevant? Yeah, absolutely. So the definition of the agent includes the interface that it walks around with, both the incoming and the outgoing aspects of the interface. And then we're going to characterize how those interfaces are connected to each other. So like, let's just say we have two people and they can each speak and hear. So we're going to have like the active state of speaker A connected to the sense state of listener B, and then vice versa. So we define the interface in terms of like what the agent carries around with it, and then we connect the parts of the action and sense that we want to have sharing information.
Perfect. Okay.
Cool. Any other like thoughts or questions on this? Okay. So we're just going to start drafting, and in the 30 or so more minutes that we have for this section, before we like just write a kind of short abstract and put our author information, we're just gonna kind of draft what just in like pseudocode what we would want to put. So again, people can just directly edit it, but let's summarize the situation that we want to describe. So who just wants to give a description on like the kernel of what we would want to describe in this model? Like if we wanted to have some expression that we could speak in natural language and see in a visualization and have a simulation of, what would we want to say with that expression?
Oh, that's a complicated way of I'm not capturing this idea. Well, how to start with this part.
Like we want to model an onboarding participant to the TEC. Just the situation that we care about, that we want to understand or design or improve. And then
Well,
we're gonna develop that and use some of these active and informational entities.
okay, but it is should we describe like the process to expect to happen, or the things that these people that
Can I
we're
just say something? I
Yep.
just
Please,
joined,
Bulk.
and can you guys tell me what this is about? I just
Yes,
joined.
welcome. I put a link into the chat. This is a document where we've been working on. In the first part of the session, we gave some background on active inference.
Yeah, can
Which
you
is
just
kinda-
skip to the point? I don't really care.
Which part do you care about?
Well, the part where you get to the point.
Cool. Well, the point is we're doing cognitive modeling for DeSci systems. And so we're collaborating on a system of interest, which is onboarding of a person into the token engineering commons.
Mm-hmm.
And then we're going to be characterizing that in terms of the active entities and the informational entities.
Okay, yeah, right.
And that's what we're doing here. Would you like to participate or not?
Yes.
Okay, thank you. So let's think about what other entities the person will interact with or what actions they take. So what's a simple action that initiates the onboarding, or once they're in this onboarding role, what's like one action?
Can you guys hear me? Yeah, I just wanted to say I saw something really inappropriate. I don't know who it was, but can you please cut it out, whoever that was?
Okay. 1 second here. Alex, could you request to be co-host?
Give me a second.
Yeah, thank you.
I'm not sure how to do it.
Okay,
Here.
it's all good. Balk, are you interested to continue to participate, or otherwise I just will remove and we'll continue?
Oh no, yeah, I just saw something inappropriate and I thought it was like a family-friendly meeting. So please continue.
Okay, just please respect our setting. It is a family-friendly meeting, and I will not hesitate to remove if anything else is disruptive, okay?
Thank you very much. Really appreciate it, sir.
I have a question. How do I
Sure.
turn my mic on?
It's on. Do you want to ask anything
Alright.
else?
No, thank you.
Okay. All right. What action setting do we want to model?
I was thinking, Daniel, probably this initial moment could be like visiting the website. That's something that could be under that control. I mean, that under this modeling process, that's something that will trigger something, right?
Great.
To this person that we are trying to onboard.
Great. So we're going to kind of zoom in on this very small action with the recognition that one can take, of course, a lot of time to develop this model in a larger way. Yeah, here, just 1 second.
Okay.
All right. Sorry to the humans. Unfortunate how this happens that way, but at least it wasn't so bad. I'll reshare my screen. All right. But this is, in a way, what I meant with the microcosm of DeSci. How do we balance our desire to be accessible and inclusive of people who are joining? And it really can be the case that a conversation with somebody who's just starting their journey in DeSci or any other kind of science, that first conversation may literally set the tone for their life. So how can we make spaces that navigate that? And there's so many details to the affordances and what is this level of security and what is this level of access and all of that. But like, we want to bring the best theoretical apparatus so that we can actually approach this challenge instead of just another blank canvas and another square zero. How do we deal with people dropping into to a new room? Thank you, dog. I remember the conversation that enabled me to begin undergraduate research, and that postdoc could have just decided that they were busy that day. So the world is complex, and that's why we have systems engineering. And so like, this is the real learning and situation. But let us continue with this. We're just going to look at this like the most micro of all actions, which is somebody visiting the website or not, and then either seeing the website or not. So this is an action state, whether they choose to visit the website or not, and a perception state is whether they see the website or not. So in active inference, actions are selected not to maximize reward, but to reduce the discrepancy between the preferences and the outcomes. So if somebody prefers to see the website, then we hope that they take the action to see it. That's like one quadrant. Another quadrant would be people who see the website, but they didn't know that they wanted to, like they stumble across it. Maybe they're a troll. Also, you have people who don't see the website. because they didn't take the action to see it, whether or not they preferred to see it. So in this little microcosm of an action, we have the kernel of a simple human. And so it's not necessarily about making like the most sophisticated digital twin where you have all of their smell and all these senses. It's just about focusing on the actions that you actually want to model. So let's just look and just write the pseudocode, like the pseudo GNN for this person, whether they choose to visit the website or not.
Hey, Daniel, Holly also put other items to consider
Okay,
in this
okay, thank
part.
you.
Mhm.
Yes, this is awesome. I think this is where we would hope that we would go with a professional grade cognitive model of participants. And all these features sound amazing. And also other features, like maybe that it respects privacy in a legible way. So it's not just like this open-ended Web2, just like jump onto our platform and then we're going to control your mind. But it could be legible and modular with how these different pieces of information are being carried out. So the model name is onboarding of a person into the TEC. I'll show an example of what the GNN can look like when it's a little bit more written out. Just so that people can see what a more full fledged example of the GNN looks like. So here's like a classical generative model. We have perception, we have action, intervening in how things change through time, and so on. And this is the plain text. Equations we don't need for our case, but these are the connections amongst the variables. The model annotation just describes what it is. Then we have the state space. And this is like kind of like Python pseudocode. It's describing the dimensionality of each of these variables. So we described that like the person has two actions they can take, and they have two perceptions that they can have. Did they see the website or not? Did they act or not? And so we can encode that in this block. So we'll probably bring this one over because it's a good starting place for the model that we're interested in. But then you can say, well, what if there's three options? There's they don't see the website, they do see it, but they can't read it, and then there's they see it and they can read it. So you can have these flexible model compositions and you can see it in the plain text. That's really the goal of why we wrote things this way. And then you can implement that in different programming languages. So we'll just say towards, and then what Holly wrote. That's where this model is heading towards, obviously as just a small token step in that direction. So a state space block, what are the variables that we're actually looking at? Action and perception. Again, it could get a lot more sophisticated, but let's just say that action has a dimensionality of 2, 1. It's a vector with 2 options. And also perception will have the same dimensionality. This is going to be for the person. And then we're also going to have a second entity which is going to be the forum or the website, the forum website. So here, the action is serving the website or not. That becomes the perception of the agent because they're connected to each other. And the perception would be user request for website or not. This person, their action connects to the forum's sense. And vice versa. Initial parameterization. If this one were action of is 0.5, 0.5, they are equally likely to visit the website or not. We could imagine much more detailed settings too, but starting with just being equally likely or not. What direction would people like to add a few more minutes of detail on? Then, if people want to add, they can. Otherwise, I'm just gonna start a little bit on the abstract. If people want to be an author, even if they want to just make an anonymous name, it's not like Zenodo is going to stop us. But this is just, again, to illustrate the kind of full arc that we can move through in DeSci with well-intended and otherwise people and bots on through a kind of compressed version of a research program and result in an artifact so that the conversation doesn't just dissipate. We actually can lock in and build on what happens when we collaborate, which is fundamentally what science is about and what epistemic commons can be about. And even things that are incomplete or imperfect, maybe in the future you want to say, no, it is possible to do a publication within a short session. Here's the citation. So it's not like this is going to be evaluated for coming up with the most sophisticated and applicable model of onboarding. But first off, it's a step in the right direction. It's a step towards inclusion and participation in these important design processes. It may serve as a prompt for a future human or for a future language model that scrapes these databases and then does who know what with them. So when we kind of lock in our work along the way, we build collaborative goodwill amongst humans who care and with the ecosystem as well.
Holly, do you want to include your name?
Oh, I will.
Oh, please. She also helped a lot. And
But yeah, everybody who wants to can add their
actually,
information. But then I'll show it in this window, like going onto Zenodo and uploading it, so people can see this is what it looks like to just upload a paper. That is how you enter something into the scientific literature. So there's like some amazing, mediums and Substacks and all of this. And it's like you can upload to Zenodo and then it becomes a citable artifact just like everything else. And there's a lot of infrastructural work and tools and nano publication, and it'd be awesome if you could just cross post it instantly across different platforms and all of that. But we also have the opportunity to do these things right now.
I think this was such a great session. I mean, with multiple uses and yeah, and things to explore and concepts to explore too.
Cool. Yeah. Well, let's just briefly summarize it. Then we'll throw it on Zenodo. And then
Mhm.
probably close the recording before the end of the hour. And we can continue the discussion for a few minutes.
Okay.
What would be some directions for future work?
Mm. Yeah. Sorry.
And as we see again in real time, how are the values and the norms of a commons or a community enacted in design and operation? What could have been different, which we can explore soon, specifically, but just speaking broadly, what kinds of processes, how can we speak to people who have such different situations and find the kind of the fitness of the ecosystem, and how we recognize when it's healthy or unhealthy, or what would be a harmonious movement, especially in science where we're interested not just in the social good vibes alone, but also the rigor, the documentation, the professionalism, a lot of these other topics, which I think all of the remaining people here probably believe can coexist. But doesn't mean that they will or that they must coexist. And how to make participatory systems, again, that go beyond, without the social fabric, the technical contributions of the ecosystem are going to be are going to deteriorate or never function. So we really do need the human aspect, but in these increasingly augmented spaces, that's going to be a big challenge. Any other comments that people want to make on the abstract or the author list? Okay. I won't copy the authors in just yet. So if people do want to, they still can. All right. So I've gone to zenodo.org. Free website. It's actually hosted by the CERN people. It could be a ledger, but today it's CERN. Upload. Here's all the things that we published. We publish our ontology. This is an automatic connection with a GitHub repo. Every time you version a GitHub repo, it wraps it, makes a DOI. We put up transcripts for live streams, all this other stuff. So new upload. All right. Here we go. I'll add the file last, just in case anybody wants to add things. This is it's another format. Digital object identifier. We leave it blank. That means that they give it to us. Publication date, today. Title. Just going to copy the title of the page. All right. Now I'll copy in the authors. The ORC ID, again, it's not a Web3 thing. It's just a researcher ID. It's free. And it's like the DOI for a person. So it's a way that people have an identifier for their research contributions. So especially when there's just common names and all of this, the ORC ID helps. We hopefully got positive affirmative consent from all authors. That's really important. It's an example of like where there's norms that are being deployed in a new way. Like even in the legacy peer review system, you can't put someone else's, you can't publish other person's work as your own. That's plagiarism. And you can't non-consensually make someone an author. Okay, but now that's happening in a different way. But anyone here could have wanted to be an author. So some people may want to be remembered in different ways. Some people, the chat and the language models and the recording and just like there's so many angles to our trail. And that's also why we distinguished the informational from the active entities. Like thinking about it in the ant setting, the ant nestmate is the active entity and the pheromone trail is the stigmergic trail, like the niche modification that we leave. So active entities read epistemic entities, and then they can write epistemic entities. But then it allows you to really clearly articulate where are we talking about a nestmate? How are we going to make sure that every nestmate is in the right way? Again, whether it's an organization or a person, and consider mental health and career progression and all these different features that we actually care about for the system of interest. So we're not bleeding out the system to do systems modeling. With ActInf or not. It's actually like a coming to iteratively respect the complexity of the system and to provide a center of gravity or a meeting point for people who do care to serve. Version 0.1. Language, leave it blank. Keywords, active inference. DeSci. Trusted seed. Emergent teams. Coda. No other notes? Or we can just give a link even to this page. I'll turn it back to comment only. But why not? Access rights, open access, license, Creative Commons. Grants? No grants? These are all optional. This is just related identifiers. Contributors. So here we could have 3 authors, and then we could also say this person was the editor or something like that. References, you can add citations to facilitate their bibliography work. Give information on the journal. We have the Active Inference Journal. We didn't ask the International Journal Coalition. We just said we're the Active Inference Journal. Conference. Trusted Seed. Web3 XAI. Unconference. Give a link to the website. Book, thesis, and subjects. Okay. Now I'm going to come back to the file. So go to Coda. 3 dots. Export to PDF. Then we'll check that it looks okay. Looks basically fine. Obviously, if we were submitting to a conference, we could make it a little bit nicer looking. I'll shrink this one just a little bit and re-render it. Okay. Okay. All the links work. All right. Uploaded the file. Start upload. Check over our submission. We uploaded a file. We said it's other. We left it open so that we get a DOI. Today's date, title, authors, the abstract that we wrote, version, keywords, more notes, open access, Creative Commons, no funding, no other identifiers, part of the Unconference. Save it. Any last words?
Yay.
Yay. Put it in the chat. So I hope there are so many DeSci fractals, and I really do expect there to be, but I hope that this session, with all of its highs and lows, and fun and games, and theory and application, is just like a little crystal of it. Because now this is a real citation that it's as real as any other citation. And it shows so much. So with that, I will just update the page to have the publication information. Change the privileges back. But if people want edit access, just please just let me know personally or come participate. So a closing word before I stop the recording, or I guess, you know, see, you can stop the recording after this, but basically, thank you everybody for joining this session. It was certainly memorable, and it lives on in our chosen representation, chosen collaborative, consensual representation as an actual publication. And I commend everybody's attention and bravery for joining the session. So that is all. Thank you.
Thank you, Daniel. I'm going to stop the recording now.